Hello, everyone. Welcome to Sun Devil Learning Labs once again, and I'm Mr. Miranda. I will be teaching today's lesson on multiplying and dividing rational numbers. So before we start the lesson, please take out any material that you need to take notes. So just take out your pencil and paper or notebook paper. All right. Okay, so today's objective is pretty straightforward. Students will be able to, so you, the student, will be able to multiply and divide rational numbers by the end of the video. So if you feel uncomfortable with the concept of rational numbers, just revisit the video that you saw 2 days ago, where I talk and explain about it. Okay, so this lesson, we want to multiply rational numbers together, and integers are a subcategory of those types of numbers. But we're going to focus in on integers just so we can understand the rules of when we're multiplying positive and negative, when we're multiplying positive and negative numbers together. So the numbers that you multiply in a multiplication equation are called factors, and the answer of those being multiplied together is called the product. So the product is just the solution in a multiplication problem. So look at this picture, and I hope that you guys recognize it. It is a multiplication table. And what we see here on the x-axis of the multiplication table is we see factors or integers. And on the y-axis, we also see factors and other integers. And whenever we choose a factor on one axis and then on the other, and we just trace it until they cross perpendicularly, wherever they cross, that's the answer between those two numbers when they're multiplied. It was just an easy tool to help us practice our memorization of math facts. But here we're going to use it just to see a few patterns between multiplying positive and negative integers. So let's look at an example. So 3 times 2, we start at 3, and we go to 2. And we see where they cross. And they cross at 6. Let's look at another example. 2 and 3. And let's see where they cross. They also cross at 6. What I want you guys to recognize is not like the answer to these factors. I just want you guys to recognize that when we multiply a positive number by another positive, we get a positive answer, I mean. So positive times a positive equals a positive. But what about negative integers? What about when we're multiplying negative integers by positive integers? We don't see that here on this table. But the cool thing about this table, remember how I mentioned that this is like the y-axis and the x-axis? You can extend those so you can see the negative numbers or negative factors, and then you can also determine what the answer is going to be, or what the answer is going to look like when you multiply negatives by positives or negatives by negatives. So let's look at the extended version of that multiplication table. So here it is. The cool thing about this, again, you see negative integers. And now we can multiply negative by negative and negative by positive. So let's look at a negative times positive example. So negative 3 times positive 2. Let's see where those cross. They cross at negative 6. What about positive 3 and negative 2? Positive 3, negative 2. Let's see where those cross. They cross at negative 6 also. So what I want you guys to recognize here is that even though the negative numbers are different in both of these, so like in this one, negative number is 3, and here negative number is 2, both equations have only one negative number. And whenever you multiply a negative number by another positive, you get a negative answer. What about when you're multiplying negative times a negative? Okay, let's look at that example. So if we're doing -3 times -2, let's see where they cross. You get a +6. So whenever we have whenever we have two negative numbers that we multiply together, we're going to get a positive answer. So we're always going to get a positive answer whenever we have two positives multiplied together, or when we have two negatives multiplied together. But when the signs don't match, like in these two, when the signs don't match, when they don't match evenly, then we're going to get a negative answer. Okay, so if you need to write down those examples, you can pause and just continue when you're ready. Okay, so how does that correlate with dividing integers? So let's just go over what a division problem is real quick. So a division problem is just a number called the dividend divided by another called the divisor. And we're trying to see how many times the divisor can go into the dividend. And that whenever we answer that question, we get the answer to the division problem. And the answer to a division problem is the quotient. So let's look at an example. So we have 6 divided by 2, which equals 3. So before we found out that this was 3, we would have asked how many times does 2 get into 6? And we would say 3. But the cool thing about division problems and multiplication problems together is that division is just the reverse operation of multiplication. So if we reverse this into multiplication, if we make this backwards, we can rewrite this as 3 times 2 equals 6. And notice that the answers for both of these are positive, and the numbers that they're being divided by or multiplied by are also positive. So up here, we have a +6 divided by a +2, and we get a +3. And down here, we have a +3 times a +2, and we get a positive answer also. So far, we can see, because they're reverse operations of each other, division and multiplication are reverse operations. So far, we can see that the rules for the amount of signs in an equation correlate with the sign that you get in your answer. So let's look at a few more examples just to reaffirm that statement. So if we have -6 divided by 2, we get a -3. Notice that we have a negative divided by a positive, and we get a negative for the answer. If we do the reverse operation, it's -3 times 2 equals -6. And we have a negative number times a positive number, and we get a negative answer. So every time we have in our equation, before we solve an equation, if we have a mismatched number of negatives and positives, then we're going to get a negative answer. So what about -6 divided by -2? Well, -2 can go into -6 3 times. And we have one negative divided by another negative, And we get a positive answer. Just like we said, -2 can get into -6 3 times. And if we do the reverse operation form of this, it's 3 times -2 equals -6. And again, we have another positive and multiplied by a negative, and these are mismatched, so we have a negative answer. So whenever we're dealing with problems that have two numbers that we're either multiplying or dividing by, if those numbers have matching signs, then it's going to be positive. But if they have mismatching signs, the answer is going to be negative. So it seems to us now that the signs of rules between multiplying and dividing rational numbers are pretty much the same. It's just the operation that's different. So again, when I already said this, when we have matching factors with matching signs, we get a positive answer. But if we have mismatching factors, and then we get a negative answer. What if you have more than two numbers that you're multiplying or dividing by together? So what do we look at instead? We have to keep track. What I would say, rule of thumb, we have to keep track of the number of negative signs that you have in your equation. So if you're multiplying 3 factors and those 3 factors are all positive, you have no negatives in your equation. So if you have no negatives in your equation, you get a positive number. You also get a positive number if you have an even number if you have an even amount of negatives in your equation. So in here, let's say we're multiplying -2 times +2 times -2. -2 times +2 gets us -4. -4 times -2 gets us +8. So whenever you have an even amount of negatives in your equation, you get a positive. But if you have an odd number of negatives in your equation, you get a negative. So here we have 3 negatives in our equation. It can either be multiplication or division. And here we also have a negative amount. And so we can also say we also have in this bottom row, we also have only 1 negative, and the number 1 is odd. So if you have an odd number of negatives, then you're going to get a negative answer, like these 2 rows both show. And whatever I just said out loud are in these bullets on the left side here. So if you want to pause the video and take down those notes, you can, and you can continue when you're ready. So now that we understand that when we have an odd number of negatives in our equation, we get a negative answer. And if we have an even number of negatives in our equation, we get a positive. And we also get a positive if we have no negatives in our equation. So now that we know that it correlates for all numbers and when you're multiplying and dividing, then we're good to go to start solving actual problems. So here in this slide, we're going to focus in on multiplying fractions. So in this word problem that we're about to solve, pretend you're in a bakery and you see a whole bunch of donuts, and you're almost done picking the amount of donuts that you'll fill up your box with, but not quite. Okay, so if you know that 12 donuts can fit in your box, you already filled up most of the box, and you only have 1/6 of the box space left. How many spaces do you have left to fill up the box completely? So if we know that the box can carry 12 donuts because it has 12 spaces for 12 donuts, and we also know that we have 1/6 of the box that's empty, that's left. So how many spaces or spots for the donuts do we have? So what we do here is we take 12 and we multiply it by 1/6. So remember how, that whole numbers can always be written as fractions, and whole numbers can be written as fractions over 1. So 12 over 1 is the same thing as 12. Now we can multiply across, which is super easy. I love multiplying fractions because it's super easy. So 12 times 1 is 12. 1 times 6 is 6. And remember, fractions are also division problems. So we can read this as 12 divided by 6. And 12 divided by 6 is 2. So the answer to our problem is we have 2 donut spaces left. So that means we can pick 2 more donuts, or you can pick 2 more donuts because it's your box, to fill your box completely. So you can have a whole dozen. So I don't know. I would personally get like a pink sprinkled donut. I don't like this halvesies type of thing. I'd rather it would be all pink and all covered in sprinkles, but that's the closest to what I like. So I'd probably end up getting those if that's all they have. But since this is your box, you can choose whatever you want. But anyway, now that we've solved this problem, we can go on to the next one. Pause if you need to copy this down, and resume the video when you're ready. Okay, so now we're going to multiply other rational numbers, and the other type of rational numbers that we have is our decimals. So we're going to focus on multiplying decimals here. So let's look at this. So you took the box of a dozen donuts home. So connecting this from the last slide. So you took the box of a dozen donuts home to share at your family potluck. Before the potluck, your sneaky little sister ate 6/10 of the donuts in the box before the potluck started. That's annoying. How many donuts did she eat? So this should be this should be she, because it's your sister. Okay. So you have 12 donuts to start with. So you had until your sister came and ate some before she was supposed to. So you have 12 donuts. Because a dozen equals 12. And your sister ate 6/10 of that. So how do we solve this multiplication problem for decimals? Well, it's pretty simple actually. You can rewrite any whole number as a decimal by just adding 0.0 or 0/10. And when you're multiplying by another decimal, you always want to match the place value of the other decimal you're multiplying with, just so that there isn't any confusion when you're multiplying. I'll show you what I mean. So we have 0 ones. So we're gonna match the ones with the 2 ones that we have in the 12 here. Then we're gonna match up the decimal here. then we're going to match up the tenths together. Okay, now we can, because we properly wrote this down, we can start multiplying the decimals together. So 6 times 0 is 0, 6 times 2 is 12, 6 times 1 is 6, and 6 plus 1 is 7. So 0, we have to replace, we have to place a 0 in the spot that we're not in anymore. We're dealing with the ones now. So there you go. That's in the tenths. Okay, so 0 times 0 is 0. 0 times 2 is 0. 0 times 1 is 0. And now you have nothing else to multiply by. So you can add all these together. 0 plus 0 is 0. 2 plus 0 is 2. 7 plus 0 is 7. 0 plus 0, nothing plus 0 is just 0. Don't bother writing that. 720 doesn't make sense, but because we were multiplying decimals, we're going to have to, how we determine how many spaces to the left we put the decimal from the right, we move from the right to the left. To determine that, we go to the first number, we start all the way at the right, and we count all the way until we get to the decimal. And that's just 1. So we move over 1, but then we have another decimal. So we start all the way from the right and count until we get to the decimal. We move over 1 more time. And that's where we're going to write our decimal. So your sister ate, actually I already put this in their presentation. So your sister ate 7 2/10 of a donut, which is really gross and also very inconsiderate because she ate most of the donuts, and also she took a bite of one and decided like, oh, I don't want any more all of a sudden, and just left it there. So, but you're gonna forgive her because she's your sister, so that's okay. We move on. And speaking of moving on, we'll pause this video to write down the work we just did and then move on to the next slide. Okay, so now I want you guys to look at this problem and solve this problem by yourselves. And before you pause the video so you can do that, I want you to think about the number of negatives that you have in your problem and predict what your solution should be. Should it be a negative or should it be a positive? All right, you can go ahead and pause the video and solve. Oh, one more thing. You can either convert all the numbers to fractions or decimals, whichever one you prefer, whichever one you think is easier. All right, go ahead. Okay, so the way I did it, I personally like fractions, but before I did that, I decided I like to have my answers in fractions, but sometimes decimals are easy to multiply. So I did these first because it wasn't too bad. -2 times -2 and 5/10 is just 5. And I just brought that down, and then I brought down -6 down. So 5 times -6. I converted the 5 into a fraction, so 5/1, and then I multiplied across. I brought that one down too before I multiplied across. Then I got the answer of -5/6. But if you decided to do the decimal route, you should have gotten about -0.83 repeating. That's another reason why I don't like decimals, is because it doesn't look at, I mean, it goes on forever, but you can't go on forever. So what you usually end up doing is you round it to the nearest hundredth or whatever place value. And if you rounded it, you would have gotten about, it's going to look the same, it's just without the bar. So if you approximated it, it's -83/10. Okay, so moving on. So now we're going to divide fractions. But before we divide fractions, we're going to have to understand a few things. Before we do that, we have to understand that division problems can be rewritten as multiplication problems, and that we do that by multiplying the dividend by the divisor's reciprocal. And we change the sign, like the operation, I mean. So I'll show you what I mean. The multiplicative inverse, or the reciprocal, is just the number that multiplies by another number that gets you 1. So the notation is down here. A over B times B over A equals 1. And let's use 1 over 2 as an example. So 1 over 2, the reciprocal of 1 over 2 is 2 over 1. So 1 over 2 times 2 over 1 equals 1 over 1. And 1 over 1 equals 1. So that's how that's what the reciprocal, that's how it's defined. But how do we use it? We use it when we're trying to make the division problems into a multiplication problem. So again, we take the divisor of the division problem, so the second number in the division problem, and we flip it. But I'll show you why that works. So let's look at the problem so let's look at the problem 1 divided by 2. If what we're saying is true, that we can make this into a into a multiplication problem by just changing the operation and flipping the divisor. The divisor, so the reciprocal of 2 would be half. Then this statement should be true. 1 times half equals 1 divided by 2. So right now I'm just going to try to prove that 1 times half does in fact equal 1 divided by 2. So let me just multiply 1 times half, and we have to make that into a fraction. So I can multiply across. 1 times 1 is 1. 1 times 2 is 2. So I get half, and fractions are division problems. So you can read this as half, or not half, 1 divided by 2. And you see that we get this is the same. So 1 divided by 2 does in fact equal 1 times half. So I just highlighted the reciprocals there. And so you can pause the video to take these notes down if you want, and resume when you're ready. Okay, so now I'm going to have you divide rational numbers, and I'm going to have you divide fractions. So it's Saturday, mom and dad are at work, and neither you or your brother know how to cook. So, but you do have 3/4 of leftover pizza in the fridge, and you decide to divide the leftovers by 2 so both of you can help finish the pizza. So how much of the pizza did you eat? So we know that we have 3/4 of a pizza, and we're dividing it by 2 because you're dividing it between you and your brother. So to make this easier, we can use what we learned in the last slide. Make this into a multiplication problem. Make this 3/4 times 1/2, because 1/2 is the reciprocal of 2/1. Now you can multiply across. 3 times 1 is 3, and 4 times 2 is 8. So you should have gotten 3/8 of the whole pizza. And your brother should have also gotten 3/8. So there you go. That's one example. Okay, so now we're going to divide decimals. And then here's the word problem for it. Benny has 1 square mile of land. He decides to dedicate 75 hundredths of that land for farming. He wants to split up the farmland evenly into 3 equal sections so each section grows a different crop. How much of his land does each crop get? So we're working with 75 hundredths of Benny's land, and he wants to divide it into 3 equal sections. So I like to divide decimals using the long division algorithm, just because it's easier to visualize for me. So I just rewrote the divisor. Sorry, the dividend here goes inside the box, and the divisor goes outside, because we're trying to figure out how many times does the divisor go into the dividend. So how many times does the divisor go into the dividend here? So before we start the process, put your decimals where it should be. And then now you can start solving. So 3 can go into 0, 0 times. 3 times 0, 0. 0 minus 0, 0. You can bring down the 7. 3 can go into 7 2 times. 3 times 2 is 6. 7 minus 6 is 1. We can bring down the 5. 3 can go into 15 5 times. 3 can go in, and so 3 times 5 is 15. And we're left with 0 here. So we have nothing else to go into. So our answer is each crop gets 25 hundredths of the square miles of land for each crop. So you can pause the video and take down these notes. And then resume when you're ready. Okay, so I want you guys to do this one on your own. Again, think about how many negative signs you have, and also think about what's going to be easier for you converting into fractions or decimals. And also keep in mind that we do the parentheses, whatever's inside the parentheses first. Okay, pause, resume when you're ready to see the answer. Okay, so what I did, this is here what I did. You should have gotten 2 over 105, or if you did the decimal conversion, you should have gotten about 19 thousandths. So if you want to pause and look at the work that I did, and take that down in your notes, you can, and resume when you're ready. Okay, so now we're at the lesson recap. I'm just going to ask you a few questions, and every time I ask a question, just pause the video, think about it, and play the video just so you can see the answer. And every time I ask a new question, pause it again and repeat. Okay, so if you have an odd amount of negative numbers in a multiplication or division equation, what will the sign be in front of your answer? Okay, pause, think, resume. You should have gotten a negative number in your solution. So what will the sign in your answer be if in the equation there are an even amount of negative numbers? Pause, think about it, resume. You should get a positive in your solution. So what will the sign be in your answer of negative 3 5/10 multiplied by 2? Pause, think about it, resume. So your answer should be a negative number. Now solve it. Pause, write it out, and solve it. And resume when you're ready to see. So you should have gotten -7. That one wasn't too bad. So what will the sign be in your answer of negative 2 65 divided by the quantity of negative 4 times negative 3/4. So pause, think about it, and press play when you're ready to see the answer. You should have gotten a negative for your answer. Now I want you to solve this for me, please. Pause, write it down, write it out, and resume when you're ready to see the answer. So you should have either gotten negative 53/60 or negative 0.88 with 3 repeating. Okay, so there you go. So thank you guys so much for sticking it out once again in this video. And just keep practicing. There's more stuff to practice. Just look to the learning guide if you want more practice. There's going to be videos on how to, remediation videos on how to solve division with fractions, because so you can solve it with a picture if you wanted, if you had to visualize it that way. There's also extra word problems that in a document that I made. So click that link so you can see the more, so you can see more practice problems. And that's about it from me, and I'll see you in the next one. Bye.